Hello and welcome to a video on similarity criteria. So we've already talked about similar figures and now we're going to focus on solely triangles today and prove if they are similar or not. So we've got two learning targets. We're going to develop criteria for triangle similarity and then we're going to prove angle similarity criterion. Okay, let's do this. So first off we have the side similarity theorem. So you may remember that from congruence, and it also proves similarity. So what we're going to do is complete the table of ratios of corresponding sides. So luckily it's color-coded for us already. So I'm going to look at AB, which is my purple side, over my corresponding purple side, DF. So what I'm going to do, I'm going to work from the left triangle to the right triangle, and so I would say AB is 5 over DF, which is 4. Okay, now in our trusty calculator we can turn that into a decimal if we don't love fractions. So 5 over 4 ends up being 1.25. Okay, now we're going to check our other side. So BC is the base of our triangle, which matches up with FE of our other triangle. So I'm going to say 12 over 9.6. Okay, now if you type it in the calculator, 12 divided by 9.6, oh my gosh, it's the same thing, 1.25. Okay, so far so good, because if they have the same ratio, they're proportional. Let's check our last one, AC, which is our orange one. So 13 over 10.4. So 13 divided by 10.4, I'm hoping for a 1.25 and it worked. Okay, so what I just proved is all of my sides are proportional. Now, I went from the left triangle to the right triangle, and you could totally do the reverse. You would just get a reciprocal. For example, I think 5 over 4 is 0.8. So if you went from the right triangle to the left triangle, you would get 0.8 all the way down the side instead of 1.25. But regardless, you get the same number, so we know they're proportional. So based on my above answers, are the triangles similar? Yes, they are. So they are similar because the corresponding sides are proportional. Okay? If you need to press pause to write that down, go for it. But we're also going to state the similarity theorem. So the similarity, side similarity theorem says if the lengths of 3 sides of one triangle are proportional to the lengths of the 3 other sides of another triangle, then they are going to be similar. Okay? So basically, if you check all 3 sides and they are proportional, then the triangles are similar. Okay? And that is a side similarity theorem. Okay? Let me know if you have any questions. Again, if you need to write that down or put it in your own words and press pause so you can have some more time to write. Otherwise, we're going to move on. All right. Now we have the side similarity theorem, which also should look familiar from congruence. Okay? So I'm going to complete the table of ratios for corresponding sides. So GH is my purple one, and LK is my purple one. So I'm going to use a purple color. So 5 over 7.5. Okay? You would type that in the calculator. 5 over 7.5 ends up being 0.6 repeating, which is the same as 2/3. So 0.66666 is 2/3. I'm going to try HI, which is my base, in JK. So 7 over 10.5. Type that in. I get the exact same crazy long decimal. So 0.6 repeating, or we know that is 2/3. Now, I don't have 3 sides to check on this one, but I do have to check that the included angle, because remember when we did side angle side, the angle has to be included in the middle. So I have to make sure that H is the same as K, which it is. So 70, what was it, 70 equals 70? So they're congruent, okay? So remember, angles are always congruent, sides are proportional. So based on my above answers, are the triangles similar? The answer is yes. So since the corresponding sides are proportional and my corresponding angles are congruent, I know my triangle is similar, okay? So now that means, oop, that's a typo. That should say side angle side. Similarity theorem. Go ahead and fix that on your paper. All right, this one's a little bit wordy. So the side angle side similarity theorem says if the lengths of 2 sides of one triangle are proportional to the lengths of two sides of another, and the included angles are congruent, then the triangles are similar. Okay? So press pause and get that down in your own words, or you can copy mine, but we're going to move on. Okay. All right, last but not least, angle-angle similarity theorem. Now this is a new one because we said angle-angle did not work in proving congruence, but it does work in proving similarity. So if you'll remember, we talked about dilations, making things bigger or smaller, and if you make something bigger or smaller, their angles are not going to change. Okay, if I have a small square, it still has 90-degree angles. If I make a big square, it still has 90-degree angles. So this is why angle-angle similarity works. So I don't have to check the sides, so that should definitely say angles. All over typos today, okay? So I just need to make sure all my angles are congruent. So n is congruent to r. I've got 70 is equal to 70, so that works out. I need O to be congruent to P, which 50 is equal to 50, so that works out. And then I have to find my missing angle just to make sure. And so remember, triangles add up to 180. So if you wanted to find your missing angle, you'd say 180 minus 70 minus 50, and that'll give you what is left over, which is 60 degrees. So 60 is going to equal 60 degrees. So since all of their angles are the same in the triangles, they have to be similar. Okay? So based on my above answers, are my triangles similar? Yes. So since all the corresponding angles are congruent, the triangles are going to be similar. All right. Now the next one, it says, without knowing the measures of Q and M, how are we able to prove the triangles are similar? So notice it's called angle-angle similarity. It's not called angle-angle-angle similarity, and there's a reason for that. So because I know triangles are 180, and if I know my two angles, I know I can always find my third one just by subtracting based on the triangle sum theorem, okay? So if I know two of the angles, I automatically know the third one, and so that's why it's just called angle-angle similarity, and that's why I only need two, okay? So let me say that again. We know triangles add up to 180. If I know two of the angles of a triangle, we can always find the third one by subtracting them from 180. So that is why we only need to prove two angles are equal. Okay? So if you have two angles that match up with two angles in another triangle, we know they have to be the same triangle and they're going to be similar. So then that leads us to our fancy theorem, which is if two angles of one triangle are congruent to two angles of another triangle, then the angles are similar. Okay, so remember, angles are not proportional. They have to be the exact same number. They have to be congruent. Okay, and that's it. So there are only three theorems that prove similarity: side, 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 angle, side, and angle, angle. So a lot less to remember. Okay. Again, press pause if you need to write that down or put it in your own words. But you're going to try the next problems on your own. So it's a check for understanding problems. So I want you to try A, B, C, and D, and E. And so you're going to be telling me the similarity criterion, which is the side, 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 angle, side, or angle, side, angle. That can be used to show that these triangles are similar, if any. Maybe they're not. Okay, if they're not similar, just write not similar. So press pause and show those on your own. All right, so answer is on A. These are not similar. So if you find the missing third angle, you get 25 and 40, and you don't have two angles that match up, so they are not similar. On B, if you look at the first triangle, this box means 90. So if you take these two away from 90, you get 55. And you can kind of stop, because I know if this angle is 55 and this one is 55, and then 90 and 90, I know the other one has to be 35. So yes, they're similar by angle, angle. On C, if you remember, these tick marks means they're congruent, and so I cannot have a side, I think this gets a third bigger, so I can't have another side stay the exact same, but another side get larger or smaller, depending on which way you're looking at it. So C is not going to be similar because you've got a congruent piece that's not going to be proportional. All right, On D, you've got isosceles triangles, and so we know isosceles right triangles are always going to be similar because 9 and 9 change to 6 and 6, so they're always going to be proportional, and then you've got an included angle, so side angle side. E was a little tricky because they gave you too much information in the left side. I did not need to know that 38. Cool, they gave it to me. But I checked the smallest side over here first, which was 10, and then I checked the smallest side over here, which was 5, and 10 over 5 is 2. Then I checked the largest side, which was 18. The largest side on the right was 9, which was also 2. So far their sides are proportional, and since I have the included angle is the same, that would be a side angle side similarity. Okay? All right. Let me know if you have any questions. But that is how to prove similarity. And now we're going to do a little compare and contrast because we've talked about congruent and we've talked about similar. So first up, the symbol for congruent is a congruent symbol. So a tilde, nope, no it's not. That's wrong. It's an equal sign with a squiggle on top. Okay? Similar takes away the equal sign and you're just left with the squiggle mark. Okay, so definition is all parts congruent, so all angles and all sides are the same for congruent triangles. Similar triangles is going to be where all angles are congruent, so that's the same, but the sides are not going to be congruent, they're going to be proportional. So my sides are proportional, but my angles are congruent. Okay. If two triangles are the exact same, that would mean a scale factor of a 1, because if I multiply by 1, that's not going to make it bigger or smaller. Similar triangles, it's either going to be greater than 1, so like scale factor of a 2 would make it bigger, scale factor of a 3 would make it bigger, or it can be less than 1. But bigger than 0. So I can't have a negative number in similar triangles, okay? So it's going to either be bigger than 1 or smaller than 1, but it still has to always be greater than 0 because I cannot have a negative scale factor. All right. And then, how to prove them. There were a lot more in congruent. So congruent was side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And then hypotenuse leg. So that had 5. And then we learned that this similarity only has 3. Side, angle, side. Side, side, side. And angle, angle. Okay, so the bad word in geometry still never comes up. Okay, so SSA backwards is not on here. All right, so hopefully that puts a bow on congruent triangles and similar triangles and how they are similar yet different. Okay, now before you go on to practice, let's do one more example where you get to try them. So I want you to try 1, 2, 3, 4, 5, and 6. So what it wants you to do is tell me whether the triangles are similar, and if they are, write a similarity statement. So remember, a similarity statement is triangle blah 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 is similar to triangle blah blah blah. So tell me yes or no and why, and if yes, write a similarity statement. I'll underline it for you. Okay, press pause, and then we'll go over them and we'll be done. All right, so number 1, they are similar by angle, angle. You have vertical angles that you're allowed to mark, and then these lines over here mean parallel. So you have alternate interior angles coming back. So you know angle A is congruent to angle D. So then you know 2 angles are congruent in both triangles, so angle, angle. So my similarity statement was AEB was similar to DEC. You could have had them in another order if you wanted to, etc. Number 2 was a no. I knew an angle and a side, and that is nothing. Plus the sides were congruent, which I know can't be true. Number 3 was another angle, angle. So these lines right here mean parallel. So in this case, I had corresponding angles. So angle L and angle O are corresponding, which I know are congruent. The tricky part might have been for you to see N. So I have a triangle on top of another triangle. So they are sharing angle N at the top. So they have to be the same measurement for N if it's a triangle on a triangle. Okay? So I know N is the same as N, and then I know L is the same as O, and so that is why it is angle-angle similarity. So then I wrote my similarity statement MLN and then PON. Okay? Number 4, this would be a known. So I had vertical angles going, but then I knew nothing else, plus those means congruent, and that would not work out. Number 5, it is similar by side angle side. So I checked the largest side first. The largest side over the largest side equals 2. Largest side over largest side equals 2 also, and then they have the included 90-degree angle, so side angle side similarity. So then I wrote my similarity statement. I said TUV, and then I said UWX. You could have had it in a different order. And then last but not least, we had an isosceles triangle because I had 2 of the same sides. So I only checked the one side, or the 26 and 13 side once, because it'll be the same of a 2. 30 divided by 15 is also a 2. Now again, you could have gone right to left, and you would have gotten a half for your scale factor, but that's good. So because all the sides are proportional, it would be yes by side, side, side. And then my congruent statement was MNL and QOP. You could have had them in a little bit of, these last 2 letters could have been flipped up in both of them. You still would have got it right. Okay, so that is similarity statements and criteria. And so hopefully you can now identify the similarity criteria to prove if 2 triangles are similar or not. Thanks for watching, and good luck practicing. Let me know if you have any questions.